Hello class, and my name is Teacher Rachel, and I'm going to take you through this wonderful topic known as composite functions. Anybody who has any clue about composite function that can share with us about something referring to composite function. If none of you can share with us, let me explain to you the meaning of composite functions. A composite function is a function that combines two or more functions. It is denoted as f naught d of x, which is the same as f d of x. And this means f d of x means that d of x in this case is the inner function, and f of x is the outer function. Are we together, class? So after looking at those meanings, we are also going to look at the applications of composite functions. Applications of composite functions. This means where are the composite functions applied? Where are they used? Okay, they are uses. Our first application of composite function is calculus. These composite functions are used to find derivatives and integrals. They are also used in algebra. These composite functions are used to solve equations and graph functions. From here, we are going to proceed to our examples. Suppose we are given, if we are given our example 1, given f of x equals to 2x, and g of x equals to 3x plus 1. And we have our questions here that find, our Roman 1 says find f g of x. Our Roman 2, f g of 2. Our Roman 3, g f of x. And our Roman 4, g f of 2. So here we are going to have our solutions here. First, looking through Roman 1, they have told us to find f g of x. In this case, you have to first find the inner function and the outer function. So, class, share with me. Anybody who can tell me the inner function and the outer function? In this case, our g of x is the inner function, and our g of x is given as 3x plus 1. And our outer function is f of x, which is 2x. So they have told us to find f g of x. So here you are going first you put the outer function out, then you substitute in the inner function, which is 3x plus 1. 3x plus 1. So we are having f into 3x plus 1. And our f of x is 2x. So here we are going to substitute. Where there have been x, we have replaced it with 3x plus 1. So we are going to put here 2 into, we are having our x there, so we are going to substitute it. We are going to substitute in this 3x plus 1. If we open our brackets, it's going to be 6x plus 2. After they told us, our Roman 2, they told us to find it. They told us to find f d of 2. So here, the answer you have got here, from f d of x, we have got as 6x plus 2. But the value of x is 2. So where there is x, we are going to substitute in 2 plus this 2. Our answer is going to be 14. Are we together, class? So our Roman 3, they have told us to find g f of x. In this case, whenever they have told you to find these functions, you have to first identify the inner function and the outer function. For this case, our inner function is f of x and our outer function is g of x. Our f of x have been given as 2x and our g of x is 3x plus 1. So they have told us to find the g of f of x. So we are going to put our outer function out, which is 3 into, don't forget to put the equal signs, then you substitute in the inner function, which is 2x, then plus 1, which is 6x plus 1. Part 4, they told us to find the g f of 2. If we substitute here, we are going to get 6 into 2 plus 1, which is 13. And this gives us a conclusion that for any two functions, f and g, for any function f and g, f g of x is not equivalent to g f of x, according to our solutions we have got in our first example. Thank you.